Whoa, spooky bell ringer.
Da 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 do 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 da 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 do do. All right. Da 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 do do do.
Hey
Da
now.
da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
All right, so enzymes increase the rate of reaction.
All right, this is a reaction with an enzyme. Reaction without an enzyme.
And they make reactions go faster or slower, but they're influenced by many things, including pH, which is what we've been talking about. Right? pH is the relative acidity, or as you know, how many extra hydrogen ions are floating around in solution. So pepsin, the enzyme that digests protein in the stomach, works best at a very low pH, a very acidic environment. Right? Amylase, which digests carbohydrates, only works at a very almost a neutral environment. It actually works in an environment that's 10, 100, 1,000, 10,000, 100,000 times less acidic. 100,000 times. That means 100,000 times fewer hydrogen ions floating around. And then some enzymes, like arginase, works best in a basic environment. Right? So pH is one of the conditions at which enzymes work. And we're going to be studying that in class and in lab over the next few days. It was cool about yesterday's class. It reminded me of the good old days of pepsin man, who you remember, right? In the stomach is an enzyme. And that's what we're moving into studying enzymes. And one thing about pepsin man we know is that he only works at a low pH, otherwise known as an acid condition. Right? And pepsin man speeds up the breakdown of protein. So what it means is an enzyme, protein would break down. Because pepsin there, it breaks down faster, right? Breaks down faster. And protein is broken down only in an acidic environment. If you turned the acidity, if you turn the pH up and made it less acid, you would get less protein digested, right? Protein is found in like meats and cheeses and beans and stuff. And what really happens is in the stomach, big proteins are broken into smaller polypeptides. In the duodenum, in the small intestine, that's when they're broken again by trypsin. But trypsin needs a buffered pH. Trypsin only works at around a pH of 8. So yeah, part of the job of your pancreas not only is to secrete trypsin, but also to secrete some buffer, something to neutralize the acid. So yeah, if you haven't picked your Halloween costume yet, maybe you should go as Pepsin Man.
Time for another spooky bell ringer. Hey, see if you can answer some of these questions. How many times more acidic is vinegar, a pH of 3, when compared to like lemons, a pH of 4? How much more acidic? Sometimes you need to neutralize an acid with a buffer. What happens? And finally, when talking about pH, most of the chemical reactions in your body take place at a standard pH, which is fairly close to water. List a place that you know where the reaction needs to be in an acid environment inside of your body.